right, cool kids. Why was the parabola going down? Logically. Not, because we could go ahead and we could actually go to this page and figure out why it's going down, the only way that it works anyway. But logically, why did I know it had to go down?
Because the vertex is at the origin and there's a vertical asymptote on top of the origin.
Yeah, the vertex is at the origin from the beginning, and what changed in the next one? Instead of having a focus at 2, 0, the directrix was at y1, or y equals 1. What kind of line was that? Horizontal, right? And what is the parabola not allowed to do with the directrix? Touch it or intersect it at all. You guys see if it was going to the right, it would hit it. If it was going to the left, it would hit it. If it was going up, it would hit it. The only way to finish was going down. But how did you get an equation? What did you guys do? Ooh, x minus 0, because it's not right, left. Good. Squared equals. X minus 0.
It was y minus 0 squared.
Y? So why couldn't we just copy from the one up above? Because this one was facing what direction? Right, left. And this one was facing what direction? Up, down. Down specifically. But they're two different models. They had to use two different equations. And so for this one's model, or for this one's equation, we use the x minus h quantity squared equals 4 times p y minus k. And question, I heard this one being thrown around. Why did I make p equal to a negative 1? Yeah, so p's sign can actually just be found by whether you have up or down or right or left. Does that make sense? Down's going to be a negative, up's going to be a positive. If I have a right-facing parabola, p is going to be a, and if I have a left, it's going to be a, got it. Does that make sense? That's the logic behind. Now, if anybody wants to take a quick picture of this with like a phone or something and they want to look at it later and not have to go back to the video, you may. You may. Some of you got some of it down, but maybe not all of it. I'm trying to make it as big as I can. You still see it all? But guys, what we just said about p being greater than 0, less than 0, greater than 0, less than 0 is illustrated in this fact. Okay, let's keep going because we're going to do as many examples today as we can. I call it the critical thinking approach in the sense of like the logical approach, if you want to think of it that way. The pattern approach, not the formula, but the pattern. They're going to give you clues. All of these are puzzles. They're going to give you clues and you're trying to figure out the parabola that's behind it or the parabola that meets it. Does that make sense? Let me give you a second to get down the clues. Your goal, find the standard form of the parabola. And to be honest, kiddos, the bulk of today is examples. The one new idea has to do with a tangent line. Very geometric, very intro to calculus. But kind of tricky because it's not calculus yet. You're learning a geometric way to do what calculus would do a totally different way. Much easier way.
Use the y minus k squared, right?
Y minus k. What have you guys done so far with your clues? Looked at them really hard and said, yay. Gone to your picture and said, hey, wait, I think I can figure out which one works. Or gone to a graph and say, hey, what's it look like? I'm going to go to the graph and say, hey, what's it look like? That's my critical thinking approach. But you could also go back to the table on the other page and say, hey, wait a minute. If I have a directrix x equals negative 2 and a focus at 2, 2, I bet that fits one of these patterns. Let's see. Which of these has a directrix as x equals? Oh, these ones do. Nope, that's not the directrix. That's the axis. Sorry, my bad. The other way. These ones have an x equals directrix, so I know based on the x equals, it's going to have to be a right or left. Since the focus is to this direction, it's going to have to, that's how you could use the chart with these clues. The graphical way or the critical thinking way says, hey, what's it look like? I don't know. Where's 2, 2? Here-ish, is that okay? Okay. Where's the directrix? You guys remember x equals -2. You go on the x-axis, go to the tick mark of -2, and what do you do with it? Make it a line. Make it a line. What is the only way my parabola could be going such that it would eat the focus and go the opposite way of the directrix? Facing the right. See the difference? The graphical way says, well, it has to eat the focus, right? Oh yeah, and then it's not touching the directrix. Now hold on. Where exactly must it be? Do you guys remember that P is equidistant from the vertex to the focus and the directrix? So what we do is figure out, hey, what's this distance? What's that distance? 4. And we cut it in half. Where's half of 4? Right there. So what we're going to go ahead and do is say, okay, so think about the distance, which is 4. Cut it in half, 2, and say, okay, go 2 in from the focus. Go 2 in from the directrix. And where do you end up? The vertex. Go 2 in from the focus, go 2 in from the directrix. Where do you get? The vertex. So the vertex is going to be what point, kiddos? 0, 2. Can we start using that to fill into our general form and question, why am I using the y minus k1 squared? Because it's sideways. Good. Does that make sense? It's right. Oh, not squared, not squared, not squared. So what can I plug in given what I've been able to figure out? Good, I can do y minus what? 2. Remember, fill in to the k and fill into the h. The x and y need to stay. They're my equation makers. Then add the squared. Good. Equals 4 times, I need my p, but let me put in my x minus real quick. X minus h is 0, right? Have we figured out what p is? We had to find p in order to get to our vertex. P is half the distance of 4, so p is 2. Why am I putting in a positive 2? Because it's going to the right. Now guys, I'm just trying to approximate. We're not going to find the whole thing. We could find the y-intercept and be super snazzy. I'm just trying to give you a rough sketch real fast. Since my parabola would be going to the right to eat the vertex and skim, not hit the directrix. Has to be facing right, hence I make the p a positive 2. Now, if they say standard form, I mean, this is pretty and all, but it's not what they want. How would I get standard form? Yes. Well, I'll simplify some stuff first. 4 times 2 is 8. X minus 0 is x. Technically, since it is an inverse, we could do x is equal to 1/8. Y minus 2 squared. We get a variable by itself. That's okay. That's okay. And technically, Luca, what you were trying to say would also be okay, which would be solve for y. We would get plus or minus square root of 8x. Technically, plus 2 equals y. So that's messy. I don't like it as much. Plus 2. There we go. If you were to solve for y, you would end up with the last one. Kiddos, I think all 3 of them are fine. They just want to see some sort of simplification. Yeah, Kristen.
How did you get the 0 again at the top?
Oh, from the vertex. So I knew that, if you draw a line from the focus to the directrix, like a straight line, sometimes it's horizontal, sometimes it's vertical. I know the vertex has to be on that line and has to be on that line at an equal distance from each of them. So once I got 0, 2, then I was able to go ahead and plug in. My h is 0, my k is 2.
And then where's the p come from?
The p comes from the actual distance itself. So since there was 4 in between, we could think of 2 to the directrix and 2 to the focus. And that common constant number, which is what it will always be, is how you get p. Just make it positive or negative based on the orientation. Does that make sense? Any other questions about how we worked through this one? The graphical approach. So graphing it lets you guys know, or lets us know, which general form to use, because it gives us the idea. Oh, hey, it's going this way, and the focus is here, directrix is here. And the rest of it, we have to go through and think through how to find each of those different clues. Now, let's do something else. I think I have an example on the next page. Let's go see. Oh, I have an application. Let's get to that one last. I did not give you guys very many examples, huh? Let's go to this one. I don't want to talk about the application problem quite yet. Let's see a different type of example. Find the vertex, focus, directrix of the parabola, then sketch it. So this is a little different. They didn't give you a graph, but they didn't give you clues. What did they give you? The equation, yeah, and they're having you find the clues yourself. So this one they're having you work backwards. Yeah. Okay, look at us. How can we make number 32 look like a standard form? What do you guys think? Okay. Expand it meaning? So you put the 3 there. This would be y minus what? This would be x minus what? In order to work, right? We could think of it as y minus 0 and x minus 0. Careful, not p. Doesn't 4p have to equal 3? So that's going to be a little bit harder. We're going to have to go ahead and say, uh-oh, so 4p is equal to 3, which means p is equal to what? So then if we were to get a graph, I don't know why, my brain just kind of works better in graphs on this. Once again, you can go back to your chart and say, hey, I have all this information, so how would I put it all together to get the different answers? But what I would say is, hey, figure out what you have. Do we know our vertex? Yeah. What is it? 0, 0. Based on the y being squared, do we know what type of parabola it's going to be? Sideways, because the y is squared. And since the 3 is positive, is it going to be right or left? So that's a rightward facing parabola. I know that p is equal to 3/4, and I know my vertex is 0, 0. From that, you guys can get all the rest. Because if it's facing to the right, then question, that's not supposed to be part of the answer. How do I get to my focus?
You get the vertex and the p. And from the vertex, you double p.
Nope, from the vertex, I go 1p. If I'm going to the right, isn't the focus going to be over here? Go right to the focus, go left to the directrix, right?
Oh yeah, you double it from the directrix, yeah.
So go right to the focus, go left to the directrix. So I'm going to go back 1/4, 1/2, 3/4, 1. Go back to the directrix. Does that make sense? Would that work with the rightward facing parabola? So now we just have to go ahead and state what we just figured out. We'll then look at the graph, kiddos. What point is this focus at? 3/4, 0. Which the pattern on the page before would say, oh, the focus for this type of parabola is going to be h plus p, comma, k. That's exactly what we did. We kept the y value the same, and the x value, we started with the vertex, and we added 3/4. 0 plus 3/4 is 3/4. The directrix, where do we end up at with the directrix over here? It's it's a vertical line, so x is equal to, because it hits the tick mark on the x-axis, -3/4, which the formula would say on the page before, because it would say, oh, sweet, the directrix is going to be x equals h minus p. So once again, the formulas work, kiddos, but if you can get the visual or the graphical feel for these, then maybe you don't even have to memorize all those formulas. You see what I mean? Formulas are good, and so maybe that might be the best way to go. Once you figure out if you're rightward facing, once you figure out if it's that type of formula, you can just plug into formulas to get the focus and directrix. But if you can get the graph, you can say, oh, no big deal. Focus, directrix, vertex. I've answered all my questions. 0, 0. 3/4, 0. X equals -3. Does that make sense? So tomorrow I'm going to totally ask you guys which ones of you just ended up using the formulas in the chart, and that's okay. I just want to know, like, for my own purposes, how many of you ended up using that. And I'm going to ask how many of you were able to use, like, the, hey, try to take the equation, graph it, and figure out the clues that way. Let's do one more. This one is just a little bit harder. Anybody know why?
Because it's in the other standard form.
Yeah. It's in the other standard form. And technically, kiddos, couldn't we have, back here when we did this example, in standard form, couldn't we have gotten it in that big old long standard form? Do you know what that would have looked like? We would have squared the y, FOILed. Then we would have gotten everything on one side, so we would have had y squared plus, nope, sorry, subtract 8x, minus 8x minus 4y plus 4 equals 0. That would be the standard form. Like ax plus by equals c is the standard form of a line. You just move all the x's and y's to one side. That's another way of writing it. And sadly, that's what we've been given in this example, right? Ugh. What can we figure out? You guys go look at your standard, what are they actually called? The clue equations. Where are they? These ones. Can you guys tell which one of these we want what we have to look like?
B.
Because?
You have a y squared.
What do you have?
And you have an x squared.
You have an x squared. So who's going to stay on this side? The x. I'm going to try and get it into x minus h squared equals 4p y minus k. We're going to write goal, and that's it. Alright, so how do we get one step closer to our goal? Yeah, get the y's on the other side, right? Aren't they on the wrong side? So we have our x squared minus 2x. Let's move everything that's not an x on the other side. So we have negative 8y and then minus 9. Does that make sense, kiddos? Okay. Now what? We could. I see something else that's a little bit more dire.
Factor out the x.
Don't we have to get this to be a perfect square? Oh. How do we get something to be a perfect square if it's not naturally so? We say it's not complete yet.
Oh
Yeah.
my.
It's okay, I was waiting for the groans. We have to make it a perfect square, or else we can't factor it to be a perfect square. We have to make it a perfect square, or else we can't factor it to be a perfect square. So what's missing? A 1. How come? How'd you do that, Luca?
Divided by 2 squared.
He's doing the trick of divide by 2 and then square both sides. Sorry, not square both sides. Square the fraction, which is square top and bottom. So negative 2 cut in half is negative 1, and negative 1 squared is 1. That's what goes there. What you do on one side, do to the. We're working with two sides on this one. If you guys don't like that as you could think about negative 2x could have come from negative x and negative x, which means x minus 1 is what I want it to match. Maybe you could think about, like with grouping, negative 2x, if it's a perfect square, they'd be the same. So negative 1x, I need a negative 1 down here. Then think your final term would be negative 1 times negative 1 is positive 1. There are a few different ways of doing complete the square. What do you guys get on the other side? Ooh, doesn't that actually make this side better? Yeah. So that, Sean, that's why I was waiting to be like, wait and see. Y plus 1. Does this look a bit nicer? Okay, let's box it and be done, except they asked us to do what? Get your clues out of here. So now we have it in the form that we can go ahead and treat like the one up here. So what's something that we can fill in from our 3 things that we're supposed to find, which is, yeah, H and K we can find right away. The focus and the directrix. Some of you might be going now to the picture that you took or to the page that you wrote down to try to fill in the formulas. The rest of us, though, if you don't mind, we're going to go to a graph and say, I wonder if I can figure out what he looks like. But as Luke said, we can already say H and K. What's H and K, guys? Yeah, careful with the X and with the Y. So I'm going to go ahead and graph my, let's see, negative 1, nope, 1, negative 1, it's the same thing. Okay, I have my vertex. Question, kiddos, what's P? Some of you have already gotten there. For the rest of us, that were kind of like, Remember, this guy comes from 4P. So that means that 4P has to equal negative 8. So then P is equal to negative 2. That's how they got negative 2. Wait, negative 2, then where's the focus? Is it to the right because the parabola is facing right, or is it to the left because the parabola is facing left? Oh, x is squared. I was stuck on the last example. Struggle. Is it above it because it's an x squared? 2, or is it below it 2?
Below.
Which way is my parabola going? There's a negative in there. I could divide that negative to the other side. The squared could be a negative, thinking about the old school, like concave up, concave down thingamabob. If my P is negative, that means it's not facing up, it's facing down. So where's the focus? Down 2. You always have to eat the focus. He's in the concavity. The mouth is eating him, right? Because of the negative, I'm facing down, my focus is down. Where's my directrix? Up 2. See it? Focus is in the concavity, the mouth is eating it, down 2. The directrix is back 2. It's the opposite direction. Now we just have to say, all right, cool, how do we write those down in order to answer it? Well, what point is that focus, guys? Careful, X first. Struggle. Negative 1, go down 2 more. Your formula would help though, because if you did memorize the formulas for this one, it would be, your focus would be H, comma, the H stays the same of the vertex, comma, K minus P or plus the negative P. And how do we describe that line up above? Y is equal to? Positive 1. That's a positive one. Oh dear. Maybe we should memorize some formulas. Anyways, so we end up with our final answers of 1, negative 3, y equals 1. The critical thinking analytic, I shouldn't say analytic, logical approach, graphical approach. You get hit on the graph, and then you have to pull the answers out. The formula way, can I go back and show you the formula real fast? The formula way would say, hey, hopefully with the negative p, you figure out that it's facing down. If it's facing down, there's a little formula, plug in. Know that k is the y of the vertex, find p. And then for your focus, know that k is the y of your vertex, add p. So the formulas, once again, maybe it's the easiest way for some of you, because interpreting the graphs is going to get way too hard. With that, kiddos, let me see if I can rearrange my notes real fast. Can I rearrange my notes? Maybe not. Nothing, I can't move it anywhere? Never mind. Okay, just pretend that our examples actually go in order and the notes will be online. Here's one application real quick. One kind of cool application of a focus. Has anybody ever heard of a parabolic reflector? No? Has anybody ever used a flashlight?
Yes.
Okay. Then you know what one is even though you haven't seen one. You guys know the old school flashlights with like the big old thick, and you have this and you can unscrew the top and then you can like see inside? It's a parabolic reflector. Why? Because it's a parabola. Where do they put the light source so that all the light goes one direction? Focus for the flashlight. At the focus. They have the light source B, the light bulb B, the right size, so that this will hit the parabolic reflector in a way that wherever it hits, because light goes out from all directions of a light bulb, right? If you put it at the focus for a parabolic reflector, it makes all the light go in that beam that you're trying to direct. That's kind of cool. So maybe a focus is something kind of important. Because it focuses the light? Oh, wow. Okay, write this down. Even though it's a cool application, I wanted to make sure you guys saw it. So I'm like, oh yeah, that is really cool. Practical application of the focus. It focuses the light. Slope of tangents. Slope of tangents. That's why many professional photographers don't hold parabolic reflectors when they're trying to give you natural light. They hold flat ones instead. They're always flat, aren't they? Yeah. They're not parabolic, or else it would direct it like in one place, and that would be a messy picture. It's more like a spotlight than like a natural enhancement of the light. The last application, finding a tangent line to a parabola at a point. And we barely introduced this the other day. Long story short, this idea of finding a tangent line to something other than a circle was one of the big reasons as to why calculus was developed, found, discovered, invented. Depends how you look at it.
Is it touching point P?
Yeah, it touches a point P. So point P on this one is the point of tangency. Think in geometry, it'd be the one point that it skims in the local region and the region right around where it hits. If I zoom in really close, maybe you guys can see. See how it skims? It's kind of hard to see because of the pixels. But the parabola keeps on going, whereas the tangent line is going to start to diverge. Diverge. Hey, that word comes back. Anyway, it only truly hits at one point, the point of tangency. How can you find a tangent line to a parabola in Salvi, a parabola only because of his focus? Another application of the focus. Because if you have a point on a parabola, axis of symmetry, which every parabola has. You have a point on the parabola where you want to find the tangent line. The distance from the focus to that point will be the same distance as from the focus to the intercept on the axis of symmetry. And why is that helpful? Even though it only hits the parabola on one point, if we can find a second point using the focus, well, kiddos, what can we find between any 2 points? slope. We can't find the equation of the line if we only have a point. Don't we also need to find the slope? And it's not showing up. That's fine. So long story short, I come up here and just point to what I have written that is not showing up. Well, yeah. Back. Imagine you saw the point there. Once you have 2 points, you can make a line.
Yay!
Totally done. Okay, we're gonna be cool like this. Ready? So, example. Old school. Anybody on the video? Go see until I try to fix it soon. Example. If they want us to find the tangent line. If they say find the tangent line, what they really want is the line, and how do you know the line? You find its equation. You find its, that's not a G, that's a Q. Its equation. 2, y equals x squared, the parabola y equals x squared at 1, 1. Calculus, we start talking about derivatives right about now. Have you hugged your calculus student today? You should. They have a final on Saturday. It's not as big a deal as they think it is, but it's a bigger deal than they think it is, depending on who you talk to. Either way, coming back. We're instead going to say, hey, x squared. We know that guy. X squared looks like this, right? With the point 0, 0 and the point 1, 1. And the point -1, 1, and the point 2, 1, 2, 3, 4. What would be the focus of this one? You guys know where the focus would be? Would we write this as x minus 0 squared equals 1 times y minus 0? Isn't that 1, or doesn't that 1 have to come from 4p? So p equals 1/4. So I would make p right here at 0, 1/4. They want the tangent line at 1, 1. Well, how can we do that? We don't know exactly where that tangent line hits. But what we can do is say, wait. That tangent line is going to hit or connect, find this distance. Can I find the distance between 2 points, kiddos? And then can I subtract that distance down? Once I, wait, pause. Once I find this point, what can I do to make my line? Point slope form and find the slope. Let's see if you can do that application tonight with the computer going haywire. Sorry about the computer. Do our best. See you guys later. Bye, Eileen.